Hello everybody, welcome to this organic chemistry class, and in this class today we shall discuss one very important topic for all of you, those who want to understand organic chemistry better, and the topic for today's class is SN2 reaction. Now first of all, in order to explain this thing we have to know what does it mean. Let us write down the term first. SN2. Now in these three terms are there. First of all S, then N, then 2. Now in order to jump into it, let us write down one specific reaction to clarify this. If we consider this reaction, let us consider one CH3 group is there along with one Cl, that is CH3Cl, and this is allowed to react with sodium hydroxide forming methyl alcohol along with sodium chloride. Now look at the reaction. Now in this, if you see, you will find this chlorine is being replaced by OH group. So Cl is being replaced by OH, producing this. So in this, what is happening is that Cl is being substituted, and who is the substituting group or substituent here? OH. So in this reaction, one group here Cl is being substituted by other. So this is one example of substitution reaction. Now come to the next one, that is N. N stands for nucleophilic. So first of all write down the meaning of S, which is substitution. Then N. N stands for nucleophilic. And 2. I am just coming later on. Now look one thing. In this, actually in this reaction, OH group, rather OH minus obtained from NaOH is acting as the substituent, and this substituent is negatively charged. If any substance is negatively charged or electron rich, then what will happen is that it will prefer nucleus, because we know that nucleus is positively charged. So any group which is negatively charged will love nucleus. So this type of substances are called nucleophilic, nucleus loving. So this is one nucleus loving group which is acting here as substituent. So this reaction as a whole is known as substitution, which is nucleophilic in nature. Now the next term, which is 2. What does it mean? Now if we study the rate of the reaction, then it is clear that, and it is experimentally true, that rate of the reaction is dependent on concentration of this and on concentration of this. That is, rate of the reaction is equal to some constant which is known as rate constant into concentration of this one, that is concentration of this into concentration of this. This may be termed as OH minus. Also you may write down here concentration of NaOH, because concentration of OH is equal to concentration of NaOH. So from here it is clear that rate is directly proportional to the concentration of two molecules. It is dependent on two molecules. Since the rate is dependent on two molecules, so the reaction is called bimolecular, and bi means 2. So this 2 stands for bimolecular. So let me write down here So I hope the term overall is clear to you. What does it mean? Substitution, nucleophilic, bimolecular. Now if we write down the mechanism of the reaction, that is, what does mechanism mean? Mechanism means how the reaction actually takes place, how the reaction proceeds to form the products, and this process is called mechanism. Here we have just written the reaction where the substrate, the reagent, the products are written, but here it is not clear how the reaction proceeds. And let me write down the mechanism. Now this one may be written as this: one hydrogen in the rear side, one hydrogen above the plane, that is closer to the viewer, and this is the chlorine atom. Now from NaOH, OH minus is generated. OH minus is electron rich. In this bond is little bit polar, and electron will remain closer to chlorine, leading to the formation of partially negative charge here. This will be partially positive. Since it is partially positive, this negative charge will attack here to form a bond. Now we know that carbon can form maximum 4 bonds at a time, but if it has to form one bond here, it has to lose one bond somewhere, and since this bond is polar in nature, so this will be clipped and this will go away in this way along with these 2 electrons. So here this one is leaving the system, so chlorine here will leave the system as chloride and it will be termed as leaving group. So one intermediate product will be obtained from here, and this product may be written in this way: the central carbon, the hydrogen which was present in this, the rear hydrogen atom, the hydrogen above the plane, and this bond is going to be clipped, but it has not clipped already, so it will be represented by dotted line, and this bond is going to be formed, but it has not already been formed, so this will also be represented by dotted line. So this will be OH, this is this, and now look, this was negative, but this is going to lose its charge. So till now it has partially lost its charge, so it is partially negative. This will gain one negative charge, this will gain one electron, but it is yet to be gained, so this will be partially negative, and this situation is called, this substance is called the intermediate, and this state, the substance where in this way will be formed, is called transition state. So this is one transition state which is formed in this type of reaction. Now what will happen next? This bond will be formed totally and this will be clipped totally. So this will go away and this will be formed totally, leading to the formation of this. This is the central carbon, this is the carbon hydrogen bond above the plane, this will be the carbon hydrogen bond below the plane, and this will remain as it was, and this is the newly formed bond. So in this way, from this substrate through this transition state, one new product is obtained. Now look, in this, if I write in this way, this is called the reaction mechanism. The reaction mechanism actually is indicating how the reaction proceeds, how the reaction takes place. Now few things are to be considered here in order to explain this type of reactions clearly. First of all, the nature of nucleophile. Now here we have written nucleophile OH minus. But remember, this is not the only nucleophile. There are so many nucleophiles. Depending on these nucleophiles, the rate will be faster or slower. If this nucleophile has greater tendency to attack here, then the reaction will be faster, and anything if is used here which will have lower tendency to attack this one, then the reaction rate will be slower. So first controller of this reaction will be nature of the nucleophile. Number 2. Now if we consider this bond, this is very important for this reaction, because this bond is going to be cleaved at the end. So if this bond strength is greater, then the reaction will be slower, and if it is the opposite one, then the reaction will be faster. Now if we consider carbon fluorine bond here, then it will be least effective in cleaving. So if it is here, that is carbon bonded with fluorine, then the reaction will be slower. But if we go on changing this one and ultimately make this one Ci, one iodine is present here, then this bond is readily cleaved and it will form I minus, and it will I minus will leave the system. So this then will be termed as the leaving group. So if in any compound we write or we keep this one constant and change this one, then depending on the leaving group aptitude, leaving group tendency to be cleaved, tendency to leave the system increases, then the rate of the reaction will also increase. So that is why if we use CF, the bond will be cleaved least easily, so reaction will be slowest, and if this one is used, the bond will be cleaved most easily, leading to the higher speed of the reaction. So in this way, if everything remains the same, depending on the nature of this bond, depending on the leaving group aptitude of the groups, the reaction rate will be changing. Now come to another very important controller of this reaction, and this is solvent. Now in order to explain the effect of the solvent, just consider this portion. Let us consider this thing. This is going to attack here. Now what will happen if you hold this one? That is, just consider this thing. You are running and your friend is pulling you from back, from behind. So what will happen? You will not be able to run as you can in normal cases. So similar thing will happen here also. If it remains free, then it will be free to attack this one. So the reaction will be faster, the reaction will be facilitated. Now which substance will keep this one free? The substances which are non-polar in nature, because this is a polar substance, it is ion. If anything is used here as solvent which is non-polar in nature, like benzene C6H6, like acetone CH3CO CH3, like carbon tetrachloride. So all these solvents are non-polar in nature. Also they cannot produce proton, they cannot accept proton also. So since these substances cannot produce proton or cannot accept proton, they are also termed as aprotic. So these solvents in one word are called aprotic solvents. So if we use this type of solvents, they will not hold this one, so it will remain free and it will attack this one freely, so the reaction will be facilitated. But what will happen if we use any substance here as solvent which is polar in nature, which is polar and protic? Polar and protic means it will have poles, and protic means it will either produce proton or it will accept proton. So let us consider this substance CH3OH or water H2O or ethanol CH3CH2OH. All these substances can produce proton and also can accept proton, so they are called protic. Also they are polar, so these substances are called polar protic substances, polar protic solvents. Now if we use this one in this, then what will happen? Here the solvent is this. Now this one is partially negative, this is partially positive, so this negative, this positive will attract each other. So what will happen is that when this will approach towards this, the solvent will attract this one in the opposite side, so this will not be free enough to attack this one, so the rate of the reaction will slow and this substance, in other word, will not facilitate the reaction, it will not be helpful for the reaction. So in short we may say that in SN2 reaction any polar protic solvent will be not effective, will not be helpful for the reaction, and any non-polar aprotic solvent will be helpful for the reaction. Now come to another very important controller of this reaction, and this is size of these groups. Now let us change this substance to make it clear. Now what will happen if we substitute these hydrogens with other groups? Let us consider we are keeping there this one hydrogen, this we are replacing by CH3 and this group by ethyl group C2H5 group. Now in this we have replaced hydrogen by one CH3 group and replaced this hydrogen by ethyl group. So what will happen if this OH group approaches towards this carbon? Now this has some volume, this has greater volume, this has greatest volume here. So when this will approach towards this carbon, the volume of this will not affect this journey, but the larger volume of this and largest volume here of this will affect this one, will restrict this one to approach towards this. This and this will be the hindrance for this one to reach here, so it will not be able to reach here freely. Now if we increase the size of this group, even then it will be more hindered. If we increase the size of this, then also further hindrance will be there. So greater the size of this and this, lower will be the tendency of the reaction or lower will be the rate of the reaction. So from this it is clear that if everything is hydrogen here, that is if we use CH3Cl, then the reaction will be fastest because here no hindrance practically will be there. But if we use hydrogen here and this one is CH3, then it will be CH3 CH2Cl, that is it is 1 degree alkyl halide. Then due to presence of only one group here, it will also be effectively attacking this one, leading to this mechanism. So then this will also react in this way. But if we replace another hydrogen from here by another group, leading to the formation of this thing, then what will happen is that again the reaction will take place, but since two hydrogens have been replaced by two groups, so it will be little bit more hindered, so the reaction will little bit slower in this case. Now if we replace this one by another group, let us consider again CH3 group. So this will have larger volume. So now for these 3 groups are there to resist this one to approach here. So what will happen for this? The reaction will be almost impossible for completion in this process. So this will be the fastest reaction producing here, then this will have, then this, and in this will almost not react in this way due to the presence of 3 larger sized group here. So in this way we may say that if one alkyl carbon halogen bond is there, fixed bond is there, if we change these things, then rate of the reaction will change, and in this way rate will become slow down, and here practically no reaction will take place. So this is the effect of size of these groups. Now come to the geometry of the products obtained in this reaction. Geometry. Now what will happen? Let us consider this one. Now in this 3 groups are there. So if we change this one here also, this is CH3, so this is CH3, this group is CH3, again this is CH3, this is ethyl group, so this will be C2H5. Now look here, this was initially like this, methyl, methyl, ethyl, and in this one chloride was there. Now from this side OH is approaching. So in this state what will happen? This is in this side, this one in this side, this is in this side, and this larger group is approaching to this. So in this portion, due to bulky size of these groups, one hindrance will be there. So they will not be able to remain in the same side. So this structure will be flipped, and this will producing this one like this. This methyl will go in this side, this will go in this side, and this will go in this side. This is something like this. If you use umbrella when the strong storm is there, very often you will see the umbrella is flipped. So I hope you have understood what is flipping. So here also this type of flipping will cause. So this is the intermediate, and here this group will go in this side. So this will be CH3, this will remain the same, and this will be C2H5. So in this way the groups what are there in this side will now be in the opposite side. So this substance and this substance, if this one is optically active, this is also be optically active, but if this substance rotates the plane of polarized light in clockwise direction, then it will rotate the same thing in anti-clockwise direction. So this type of phenomenon or this type of product obtained from this is called inverted product, and the phenomenon is called inversion. So inversion of configuration. So in short, we may say that in SN2 reaction, inversion of configuration of the products take place. So I hope if you are watching the video till now, you have understood what does SN2 reaction mean and what are the controlling factors of this reaction or of this type of reactions. Now this is not sufficient for you. If you have understood from here, please go through your books, because my video lecture is not sufficient for you. It will help you a lot, but it will not be everything. So please consider your book, go through your book, then only you will have a clear cut idea and you will comment on this. You will be able to answer everything set from here. So I hope this class is helpful to you, and if it is so, please press the like button, and if you still have any question regarding this, please don't hesitate to write in comment section. And if you want this type of videos later on, please subscribe my channel, and then you will be able to get the notification once I publish any video later on. So that's all for today. Bye bye.